Welcome back to another tutorial today, whereby I'm going to talk about MQTT protocol. So in this tutorial, I'm going to see how to use MQTT protocol to send data to Adafruit IoT cloud platform we see here using Arduino programming. So this interface is just dashboard that you can create with this IoT cloud platform that use MQTT broker. So we are going to use this NODEMCU as you see here. We are going to publish value from potentiometer, and then we'll be able to control an LED connected on digital pin number 6. So without delay, let's start explaining how MQTT works. So in this video, we're going to cover this. So we're going to go through the overview of MQTT. So we are going to see how MQTT client work with Arduino IDE. Then we see how to use Arduino and the potentiometer to publish and subscribe methods. And we go through the installation of required libraries, and then we configure the Adafruit IoT Cloud platform. And then we establish a connection between NODEMCU and the Adafruit IoT Cloud platform. So now let's look at the overview of MQTT protocol. So MQTT is a protocol which is mostly used in IoT. So it is a lightweight message protocol that uses publish and subscribe operation, so to transmit data between client and server. And it uses TCP as a transport protocol. The reason why it is preferable is because its packet is very thin and require very little bandwidth. So MQTT uses a client server model. The server in this case is called broker, and there is auto operations in MQTT operations. The first one is the publish, whereby a device referred here as a client is send data to a broker or the server. And then the subscriber is the device or occurrence that want to receive data from the broker. So it means to communicate with our MQTT protocol, you have to publish and subscribe at the same time. So this is the other model, MQTT model. As you see here, the things in between is MQTT blocker or the server. And this one is a publisher. The publisher sends data to MQTT blocker. Suppose this publisher to be, for example, the temperature sensor that is attached to the microcontroller that send the temperature to the server. And then suppose that this client is someone having the computer or a smartphone who is receiving the data from the temperature sensor. So he have to subscribe to the broker, and he have to subscribe to the specific topic in which the temperature is being published to. And then the client have to connect to the broker, and then the broker acknowledge the connection. And then when the connection is subscribed, is acknowledged, you can just get the data instantly. And the client also can publish the data to any topic, and the client can send data to the device which is publishing as well. So this another graph that can explain it very well. In this side you are having sensors, okay, different kind of sensor. Yeah. So all these sensors are publishing, okay. The sensor publish data to the broker. As you know, the sensor collect data in the environment and send them to the broker or the server. So here they are subscribers, all our users who want to receive this published data. So normally they subscribe to the data that have been published to the broker, and the clients can subscribe and they also can publish, okay, can publish data to a given topic. So in these experiments, we are going to use the following, we are going to need the following materials. So the first one, we need We need an NODEMCU as you see here. Okay, we need an NODEMCU 1, and we need the potentiometer, which is this one. Okay, just a 10K potentiometer, and we need an LED, which is this one. Okay, only one, and we need the resistor. And this is a resistor, and this is one LED, whatever valve, whatever color you can choose, it doesn't matter. And then we need a couple of wires to go on for this tutorial. So before going further, we just want to prepare the development environment. So I told you that you have to use Arduino IDE. So before you start with Arduino IDE, you have to install NODEMCU board package in Arduino IDE. So when you follow this link, it explains you all steps needed to configure your Arduino IDE to work with an NODEMCU board. Okay, now after that, we need to install the following libraries. The Adafruit IO library should be installed, and the Adafruit MQTT should be installed, and the Arduino IDE client. You can search this library to GitHub or Google. They can show you the link. You download them and then install them in Arduino IDE. I think it's clear. So before going further, let me introduce you about this training kit, and it is better training kit to use the embedded system in IoT project. As you see, we have several components whereby you are having Arduino Nano, that we are having potentiometers, display, 7-segment display, a couple of LED, dot matrix display, and you can attach here RFID sensor. Okay, yeah, those are push buttons, and it is compatible with many sensors and the modules. This is the ST11 touch sensor here, and this is a temperature sensor, flood temperature sensor, and it is compatible with many. And here you have the nice breadboard whereby you can make your own circuits or extended the connection of this breadboard. Okay, now let's stop with here and start the configuring the Adafruit MQTT crowd. So before going to Adafruit cloud platform configuration, let's take a look at the Arduino code. So it is a very simple code. As you see here, this is the libraries that are needed. Okay, 3 libraries that I have mentioned there. And if you want to see how those libraries are installed, you can visit this link here. Okay, so I will put it in a video description. And when you come to this link, you will see how to install those 3 libraries. So the first one is Adafruit IO and Adafruit MQTT and Adafruit HTTP clients. Okay, those 3 libraries. So they are showing you how to go to Sketch, include library manager, and then you just click here, and then you go to manage library, and then you click here, and then you see this window, and then you tap here Arduino IO Arduino, Adafruit IO Arduino, and then this will pop up, and then you click install. For the next one, you write this number, you copy it up here, and then this one will pop up, Adafruit MQTT library by Adafruit, then install it. And another one also, Arduino HTTP clients, that is the last one, you type it here, and then it will come here, Arduino HTTP client by Arduino, then install it, and then it will be ready to go. Okay, then after this, let's continue to see how the code looks like. So this is the access point configuration, whereby you have to provide the SSID and your password of your router. Okay, and then this is for Adafruit IO setup. So this is the server, which is IO Adafruit.com, and remember that is MQTT broker. and this is the ports, and this is my username, and this is my API keys or AO keys. And then when this is configured well, then you have access to the Adafruit cloud platform. So as you see here, we started by creating an ISP Wi-Fi client class to connect to the MQTT server. And then after that, we set up MQTT client class by passing the Wi-Fi credential and MQTT server and the login details, which is username and keys. Okay. Then after this, we set up a feed called here port value that want to publish. This port value is what we want to publish. Where we want to publish to this value, to this feed, which is port value. This is considered as a topics. Okay, we want to publish it under feeds and the port value. So you will see this exactly in MQTT cloud platform. Adafruit. So also I want to subscribe because we want to turn on reds, and I want to increase the brightness of LED and reducing it using the cloud platform itself. So we want this body to subscribe. So the feed that we have to change on the cloud, it is this one. And then after this, we connect to the MQTT, and then we define the red pin number where the red is connected. Then we initialize the port value and the red bright value. And then here we are going to try to connect to the Wi-Fi, and when Wi-Fi is connected, we print connected, and then we print IP address, and then we subscribe to the feed that has mentioned there, which is red brightness. Okay, then the loop, we connect to MQTT again, then we subscribe to the feeds. Okay, here we subscribe to this feed, and then we listen to whatever value that is incoming to that feed. If we get any value, we hold up under this red bright value, and then we convert the integer that the string that is coming to the broker into an integer, and then we set that value to the LED. Here we print it, and then we set that value. We set this pin, and we set the value that we received. Okay, in this way, you can increase the luminosity of the red. Okay, we use using this function analog light. Okay, then here is where we can publish stuff. You see that we are reading the content of analog A0. Here we have connected the potentiometer, I think you remember. And then we use this simple logic whereby we take this, initialize the value to 0, and then we check if the value we read is if it is equal to the initialize the value plus 100. Okay, if we have a change between 0 and 100, okay, so the change should be greater, or should be the initial value minus 100 to see whereby we have increased by 100 or we have decreased by 100 is whereby we publish. So if this is the true, just we hold the value, and then we print it, and then we publish it. Okay, when the publish is fail, we just print fail, then that's okay. Then this function is the function to connect to the broker. So this is for connecting to the broker only. Okay, if it doesn't connect, we will say try connecting. So just you upload this code, then you see what is happening. So my code is running successfully, and then I can just click here on the serial monitor. Serial monitor, you see it is running, but it is running. Let me reset the board. As you see here, it's connecting to my Wi-Fi, and then after connecting to my Wi-Fi, it is trying to connect. Okay, then Wi-Fi connected, IP address printed, MQTT is connected, and then it sends this value 9440 and to the crowd, then I can change it. You see there that it is sending this value to the MQTT. Then let's see how you can configure the IoT platform to receive this number. Okay, and then this is very simple. We just have to go to account.adafruit.com, or just you go to account.adafruit.com, then you come directly to this login page. If you are new, you can create account. Okay, you can go ahead and sign up. It is very easy. But me, I have an account. Let me sign in. After signing in, I provide my username and the password. It was already there. Then I go straight in my profile page. So when I get here, you see here where it is written IO. You go to IO. So for you, if it is the first time you have to create an account, okay, it is free. And then when you go to IO, when you come back here to IO, so if you are signed in, if you get here to IO, just you will see this interface whereby you can see your keys, and this is your keys, okay, your API keys that are needed for this Arduino code. You see that here we have used these keys, okay, to authenticate you. Okay, these keys I'll copy it from here, okay, from here, and then you will see the feeds here. So this feed will represent your data. If you are sending the temperature, you click the feed that is called temperature. If you send the humidity, you create a feed that is called humidity. So for us, we are sending the data which is called port value. Okay, port value. So we have here a port value. So let me go ahead and delete it. Okay, let me go ahead and delete it, and then I create my own. Okay, here we go. Then let me delete this. So, and let me also delete this. Okay, and then for this purpose, we are going to create a new feed which is called the port value. It should be exactly the same as this. You just copy this, and then here you just create a port value feeds, and then this feed will contain the value from the potentiometer as mentioned. Okay, when we have that port value, it is this one. Just you click on it. Okay, when you click on it, then it's okay. You can add manual data in it. For example, you can add 50. Okay, and then you can add, for example, 20. Okay, you see that I'm getting the line automatically. Let me add this number. You can see that I'm having it's like a small dashboard. So in order to have very good dashboard, you have to come here on dashboard, and then I create a representation of my value from that feed. So I create a new dashboard. Then let me call it potentiometer. Okay, and then in the potentiometer dashboard, I click on it, and then I come here, I create a new block. And then I want to use the gauge to display the value. I click on gauge, and then I select the specific feed, which is port value. I want to present whatever value that comes from these feeds, and I want to present it on my dashboard. I click next, then I call it as quality potentiometer. and it will range from 0 up to this number, okay, because it is from analog value from the potentiometer. Okay, then here I can call it whatever value, it's not a problem. And then the high warning emission set it to 700. Okay, test value is new. Then I click create block. Okay, now I have my block here. And then after this, I can create another block of line charts, and then I select my feeds, and then I call it potentiometer. Then on x-axis, this one, there should be a time. Okay. Then on y-axis, let me call it levels. Levels. Let me call it levels. No problem. And then, yeah, that's it. It's no problem. Then, okay, I'm having the line charts and the gauge. Then also I want to go back to the feed, because remember in the codes I have to subscribe to this feed in order to turn on my RAID. So I have to create also this feed. Okay, copy it, just come here, then create a new feed and pass, I call it red brightness. Okay, and then once I have the feed, I want to create its own dashboard. And then I have to select the specific dashboard. Okay, because I want to represent this number you see is the number that I have added in the feed, and they are plotted automatically on this line chart. So I have to use another a slider here so that I can change the brightness of my LED. So I have to select this LED brightness feeds. Okay, then when I change this, let me call it slider. It should slide from 0 up to 200, 255. Okay, because I want to change it from 0 up to 255. It means 0 will be 0 voltage, and this will be the maximum voltage. And remember that it is a PWM pass width modulation signal that you are going to send on pin number 6. So this value will be 0, step size 10. There's no problem. Let's set step size to be 20. It means when I move one time, the previous value, the next value will add 20. Okay, and then I create it. Okay, codes. Okay, now it means if I change this value, I will see something on that specific feed. Let me copy it here to see clearly if it is happening. Okay. Okay. So I come here to the feeds. Okay, the feeds. Then here I have dashboard. Let me arrange the dashboard. So I can move this up here. Let me delete the screen size. You can move this. No. You can arrange this in this way. Okay. Can arrange this in this way. Okay. Ah, that is good. Then I can click on this brightness feeds, and then let me make them side by side like this. Okay, this is my dashboard. This is my dashboard, and this is my feed, as you see here. This is my feed. Okay, this is my feed. So if I change this, I should see something here happening. I put 100 and I get 100. Okay, if I change here, you see that I'm getting that change. I have this 180, 240. You see that I get 240, and the line is automatically drawn. And then when I put the 0, you get 0 here. You see that this UIs correspond is just connected to my feed. So this value I'm changing is what I have been subscribed to. Okay, I have subscribed to the specific feed. It means whatever thing that are changing to the crowd, I have to get it here. So when I get them, I send a value to this specific pin. Okay, I send this value to this pin so that can make radio one on and off. Okay, now I show. Let's try to see whether this work. Okay. So guys, as I told you, this is a simple circuit to follow. You see here that we have an NODEMCU, and it is this one that is presented here. Okay, and then you have a potentiometer connected on an analog pin number 0, and this here, it is the potentiometer that we are using, this one, and it is connected to this analog pin number 0. And then after that, we're having an LED connected on the pin number 6. So here we are going to use one of these LED. So it is this blue one. You see those LEDs, the one blue one. Okay, and as you see here, this potentiometer can be varied. Okay, so the change will be seen when we modify or we change this potentiometer. Okay. Then after this, let's see if I can change this slider, then I can, and then to turn on the LED connected on the pin number 6. So if you see here well, you see that you have a couple of LEDs. So one of these LED is connected on the pin number 6. So when I try to to change this value, you see that it is set to 40. You see that we get the low luminosity. When I put it to 120, you see that it is increased. When I set it to maximum, you see that the light is increased. Okay, so when I set it back to 0, you see that it turned on and off, and half luminosity, full luminosity, half luminosity. Okay, and back to 0. You see that the MQTT is working very good. So guys, this is what I want to show you, and I hope you have enjoyed the video. And then I will put all necessary link in the description, including the codes and how to set up Arduino IDE, and then see you in next video. Thank you so much. Now let me show you how you can change the value from the potentiometer and then send them to the crowd automatically, the MQTT. You see that if I'm changing here, you see that the dashboard is changing. Okay, and here you see that on serial monitor, I'm logging the change, whatever value that I'm sending to the cloud, and then put it to maximum as a minimum, and this is maximum. No, maximum is not reached. Okay, the maximum is reached, as you see. Okay, this is maximum one, and you see that it is done instantaneously. Okay, if I make a little change, you see that the change is reflected automatically. Okay, you see how the MQTT is very nice protocol for this purpose. Okay, I think it is very clear. So you can use this MQTT or this or protocol for just from the device up to the cloud, and this potentiometer can replace any sensor. Okay, so the beauty of this board is that you can use just different type of sensor that are available. You see that here you have a couple of push button here, okay, and you can use these are the ST11, and for example you can attach a Bluetooth sensor, and here you can just use many compatible sensors like a vibration, like so different type of analog sensor. You can use the ST11 here, okay, and then this is a buzzer, and then this is dot matrix display is located here, but this is a 7-segment display, and this is a couple of LEDs, and this is LCD 16x2, and this is I2C driver. So this board is very nice to be used for as embedded system students. So if you want to master your skills, just you can use this board to take your knowledge from one level to another. So thank you very much.